Hello and welcome back to OpenGL Part 3. Today we're going to be talking about shaders and a lot of interest because let me just start over. Hello and welcome to OpenGL Part 3 here on Code Tech and Tutorials. My name is Matt and I'm going to be your host today. Now if you've been following along, you've seen episodes 1 and 2, or at least the core parts of them, and you'll know that we are at the state where we are just drawing a plain triangle on the screen. And if we want to start getting more advanced, we have to start writing our own shaders. Now the shaders are programs that live on your graphics card that you can write, just like you can write programs for your computer to do what you want. You can also write programs for your graphics card to do what you want. Now primarily these process effects and things for your graphics in general, as you would expect, but in theory you can have them do anything. Shaders are really cool. There's another whole endless set of possibilities, and with how fast graphics cards are, you can do some really cool stuff. It's something you actually have to really hone in on, and it will pay off. Okay, so the first thing we'll notice here is we don't have any sort of shader at all in our current program, so it is just using like the default one. And the default one really doesn't give you much, and it's also even sort of hard to find details on, but it depends on what version of OpenGL you're launching. Right now we're using 4.6, but if you're using an older graphics card, you might have to go back to an older version. So this is going to vary depending on your hardware. If you have somewhat newer hardware and can do 4.6, that's fine. But also there is like 3.3, which is pretty standard for compatibility if you wanted to make sure it's compatible with most old computers. But once you go back further than 3.3, you're getting into like the 2009 and previous eras, so I would advise just not using that stuff just because it's way out of date at this point. So we are going to look at the official documentation as we like to do. What we're going to be writing shaders in is this language called GLSL. We're looking for the specifications. This is the 4.5 spec I was looking at, and this is the 3.3. If you just want to know some specific detail and Stack Overflow or random guys on random forums aren't cutting it, or get random guys on random videos, I guess on this case, aren't cutting it, you can just go and pull up this manual and find all the details for yourself. And I'll try to over explain everything, as this is intended for people who don't know what this stuff is really at all, or only have like a really base knowledge. I suppose another thing I should probably mention, as it's semi-important, is just how these OpenGL versions and GLSL versions match up. For a time way back in the day, they used to have different numbers, but starting with 3.3 and above, they actually correspond, so it's pretty easy to tell once you're on. Okay, I found this overview in one of the manuals that looks like it's a pretty good way to sort of give you a brief overview of what we're going to be doing when we get this shader up and going. Basically what we do is we handle all the positional stuff, and then we handle all the coloring stuff, and that's what we're going to be doing today, is just vertex and fragment. We're going to be skipping over tessellation, skipping over geometry, and just handling vertex and fragment for position and coloring basically. And with those, with positioning and coloring, it is enough to get all your 3D stuff going, or 2D. It is also enough to get all your lighting going, and it's enough to get all your texturing going. So with vertex and fragment you can do a lot. It's where you start wanting special effects when you do these other ones, so just keep that in mind. Okay, very good. So we've opened the project, the same one from last time, and now we just need to improve this so that we use our own shader. Everything's looking dandy enough, resizes, all that. Okay, so what's a quick way of doing this, you ask? Well, you could use a library. I don't know of any super clean libraries that do this shader thing for you. I'm sure there are some out there. Feel free to leave a comment if you know of one that's really good at setting up the shaders. But for now, I'm just going to go check out this guy's channel. This Code Tech and Tutorials channel has some videos on OpenGL. I don't know who this guy is. Definitely isn't me. And in my OpenGL, which is a sound tutorial, part 4, I actually did some shader initiation. So I'm going to go here to this cool video, and looks like a pretty cool guy, and just go to the source code here. I think I hard coded it in. And in here in the modes, top down, or I made a little top down thing. We're going to look for the area where we load up everything. So here you can see I have some functions for doing all the stuff. There's loading up a square, so we could essentially use that. I didn't, in this tutorial though, you'll notice that I did not use indices. I just straight put the points in there, which is a little slower, but I didn't care. I was just trying to get it done. But we do have this load shader function, and this is actually what we want. This has all the code we need. So that's all we're going to do in this case, is just take this whole load shader function and give it a little steal. We're just going to go maybe into rendering, I guess. I'm trying to think where to put this file. Rendering is going to be fine for now, and let's just go new item. And it's going to be a header file called, we'll just call it shaderloader.h. Sounds good. Maybe we'll call it like GSL, because it is specific to the GLSL. There we go. Just put all that function in there that it just made, and we'll have to include some things, otherwise it's not going to know how to work. We need glad for all the OpenGL stuff. I think I'm going to go ahead and just make this static, so that way there are reasons. You don't have to make it static. I'm doing that with a lot of these, and that's because I just want them to build as basically a singleton to make it super easy, and also just, you know, always be available. But we may update this later to be organized different. I don't think I'm going to be honest though, because that'll just take away from the point and make it a little more confusing. But what most people do when they're making this kind of stuff is they organize their classes in like a game engine type style. But just know that I'm not really doing that here. I'm just kind of getting the functionality going in a very simplistic form. So we're gonna make this L caps, and there's two different ways to do this. You can either pass it a file location and then open the file to a vertex shader, or you can just pass it the character array. Now, what this function is set up to do is actually handle the character array. So you pass this function the entire source code, and it does all the things. It creates the shaders right here, and it holds an ID to return. Now, this ID is just about like the VAO type stuff we were messing with. This program is built on your graphics card, and we need a way to reference it, and that's what this ID is for. So we've got all this code to do all this stuff. Now, to be honest, this code is not like too much different than you'll see on any other tutorial. Just got to straighten out a few things here and make sure it actually works. But overall, it looks like everything's here, and it does return a program ID. So I don't suspect there will be any particular problems with this, but we'll have to give it a test. And now going back to that OpenGL code, source code, we scroll further down in this file, and we'll find that in here in my init function, I have some shaders, a vert shader and a frag shader. And these are very simple shaders. I'm just going to go ahead and copy them, because that's all we really got to do. Go back to my program. Okay, so the way this load shader is built, it is modular, meaning you can pass whatever shader you want to it. You can reuse this function to build your vertex and fragment shader and get that program ID back. But if you want to expand it to have other shaders in here, like we mentioned earlier, like tessellation and geometry, you're going to have to add that to this whole mix. And all this commented out code, real quick, is for source files. So if you want to make this in a way where it's for handles source files too, you can. And you basically just got to uncomment this code and do it a little differently. Okay, so let's go back to our main program. Let's go back to our source here, which holds our main. And let's think about how we're doing this shader stuff. So we've got to load our shaders somewhere around this time when we're doing all this object stuff before we go to our main loop. So in here, I'm going to make a call to this shader loader and get that all sorted out. Now, really all we got to do is just put this data in here for a vert shader and a frag shader. So there's the source code for those programs. Now you can see I'm using 3.3 here. and that should be fine. I'm gonna go ahead and put it to 4.450. Now you could use C++ code to fix all this up. Like you could check what version of OpenGL you've opened and then kind of change this code on the fly using C++ before you upload it. So there's a lot of tricks you can do to handle this. Is the point. You can also use pragmas in this code to have GLSL kind of sort out things depending on what version you're on. And that's way more complicated. We're not going to do any of that stuff, but just so you know it's possible. Okay, so that looks well enough. So on the vertex shader, we have declared a layout at location 0. This just basically says whatever VAO you're using, location 0 or the first thing in the array is going to be the vertex position. Now that correlates right along with, you find this here, this upload mesh, because it is this vertex trip. It is 0. It's location 0. So that's what that location 0, it has to line up. So you have to build your shaders in a way that they line up with the way you're uploading your meshes, because it doesn't have a magical way of knowing which ones are normals and which ones are vertices. So you have to get them set up properly. So we know that the first area, or 0 in this case, because the array started at 0, is our position. So that's how we're going to have to handle it in our code. And when we add more stuff later, they'll have to be in the next array, and we'll have to line it up in the shader as well. So let's go back to our source here and keep looking at that. But that's what that is. And then we have a uniform here, which is a map4, a matrix. A map4 is a matrix 4x4. And that is our model matrix. We're not really going to be using that right now. So it's just going to be set to an identity matrix. But as you see here at the end, once we go to our main, we basically just set this GL position, and GL position is a keyword so that it passes it through the shader. So you have to set this somewhere in your vertex shader so that it can pass this on to what comes next in the pipeline. So we set this GL position to the model matrix times this vertex position, and we had to put a 1 in there because this is a vec3, and you have to times a 4x4 matrix with a vec4. You can't times it by a vec3. That doesn't work. It's not a legal operation. So that's why this 1 is added, in case you don't know. So that's all it does. It basically just does something with a model matrix and sets that to the position. Since we're not going to be using the model matrix right now, I'm just going to comment this out and duplicate this line, comment that out. We'll just delete it. We'll just say the position is very literally right where this position is. And that's fine. This model matrix is for when you're moving it around, because it handles transforms, rotation, and position. We're just having it right in the center of the screen, so we're not going to mess with this model matrix right now. And the fragment shader, we're going to look at this here. The fragment shader, it processes sort of like the vertex shader, just one position at a time, and goes through every one of them. And all it really needs is an output of some kind of vec3 color. And this is going to be the color of the vertex. We declared the out. It's kind of weird. You would think there would be like a GL color or something for something that's required, but it's not how it is. You just have to have an out vec3, and it automatically goes from there. And you can see we have a uniform vec3 here, which we can set. So we could set it to any color we want by just changing this uniform. Now, uniform, they are variables you can change on the fly from your C++ code. All you have to do is, well, we'll get into that. I don't know if I want to talk about it too much, but just as a quick primer, all you have to do is basically know which shader you're using. So you need that identity we were talking about earlier, this one here. If you have this, the shader program, you can just say, use that shader and update this variable. And that's how you change those uniforms on the fly. I'll just change that one on the fly and we can play around with it a little bit. So that is the shaders pretty well explained. We still need to load it, and we just need to save it as an unsigned int. So I'm going to go unsigned int. We'll just call this our main shader since we only have one right now. You can call it whatever you want. Generally, you want to identify them accordingly, because you'll often have multiple shaders that you switch between for different effects and different things. But let's keep it real simple and just use one right now called main shader, and we just need to call load shader and pass it that code of the vert shader and the frag shader. And it doesn't see it because we haven't included, but let's just go ahead and include the GLSL shader loader, and now it should be relatively happy. So we can give this a quick check by just spitting out whatever ID it gets, and then we'll just return here. That way we don't go any further. All right, fine, we'll include this real quick, but I just want to show that it gets an ID. We'll do one right here before setting it. Okay, so it should say 0 and then whatever it turned it to. Let's go ahead and have a look at that. There we are. So we got a 0, and then we got a linking program message. I think that's in that shader loader thing. And then it's now 3, so it did get the identity of 3. So that's all we wanted to do. We just wanted to make sure that that actually worked. So we'll go ahead and put it back to how it was. And I think I'm going to get rid of this print statement here. I don't really like it. This linking program right here. And I don't really like this printf, but I'm not going to worry about it too much right now. I'm just going to leave it. But I would rather have this throw or something, because you just don't want to continue if there's an error. But it does work well enough, so we're going to leave it. Alright, so we've got our shader loaded up. All we need to do now is just use it. And let's go ahead and do that. Of course, we do want to get rid of this return 0, so we continue our program now. Now, before we draw, all we want to do is just bind our shader with GL use program, and we need this main shader ID because that's the one we're using. So we do that before we go to our draw, and then it should draw using that shader. Okay, let's go ahead and hit play, and now nothing should actually be different because our shader doesn't do much. It basically just sets these positions the same, and the color is just going to be the default as we left it. It's just nothing here. So if we set this uniform, we will actually start to see different colors. So we can play around with that a little bit and just confirm our shader is working. Now, one thing we can do is just set it equal to something, so we can just have a default value for this before we change it. We'll just go back 3 and we'll say, let's make it like a gray. So we should get a gray triangle if this works correctly. All right, there we go. And yep, that is definitely a gray triangle. And since there's only 3 points, it sets these by the point. So it's setting this point as gray, this point is gray, and this point is gray. And then it interpolates between all of them, which is just a flat gray, of course. So if there were 3 different colors, you would get kind of interpolated rainbow looking look. So you do see that often in tutorials where they set each one to a different color. And generally the way you do that is not by setting it like this, but by packaging all that in with the vertex data. So there wouldn't be just a float position here, there would also be a color. And then you could assign each position a color as well. Just FYI, we're not ever going to do that because, well, I guess, you could do that as like a generic cell shading that's really efficient, which means you don't have to upload textures and stuff if you're doing all cell shading like that. But we're probably going to just use textures eventually instead. But that is a thing you can do with the colors that is pretty neat. So I think we've gone about far enough here. I do want to show you how to change this uniform on the fly, and then we will call it. Also, I noticed in the manual that there's all these block storage layouts. I probably should be using these, but I'd have to read up and study on it because I'm not a shader expert is basically what I'm getting at here. So anyone that does shaders for like a living or has a job doing it probably knows a lot more than me, but the info is all here and it is learnable if you want to do it properly. There's a lot more like these uniforms. I know, side rant again, but hey, more stuff you probably need to know if you're doing this graphics coding stuff. Okay, so the way we update our uniforms, and we're just gonna do this every frame and make it something super flashy right now, is use GL uniform. So we'll use GL uniform, and then it has a type. We're using 3F, which is a float. So 3 floats, because we're updating a vec3. So let's just use random. So I'm just going to go up here, include random, and we'll get some random colors going. Okay, and so I've added some random stuff. And all I did is, before going into this while loop, is make a default random engine generator and a uniform real distribution, which can make random floats. And we want to go from 0 to 1. And the reason is because these colors are all from 0 to 1 on the shader, with like a 0 being black and the 1 being white, I believe. So getting a random between 0 and 1 will just get us a random color. And what we're going to do is every update in this while loop is we're just going to hold a new random for C1, C2, and C3 so that each vertice will change to that color. And another thing, when you do this uniform 3F, I typed it wrong before, because before I had it so that I was trying to say main shader, which doesn't make any sense actually. But what it does need to know is which variable. You have to get its location by ID, and there's an unsigned int. So you got to use this get uniform location first to get the location of that uniform. You got to tell it which shader and the name of the variable on that main shader, or the name of the uniform. So we're saying get the uniform location off the main shader that's named uColor, and we're storing it as var because it's just a whatever name for now. So there we go. Now it is happy with it, and if we hit play here, we should see some flashiness, warning, flashiness, flashiness, warning. There it is. A bunch of different colors, super fast every frame. And that all seems to work fine. Now I should note here, because this is like where a lot of people get stuck on this stuff, it is very precisely like in this order. If you mess it up, for example, you just thought you like put main shader here and you're trying to do a uniform 3F on the main shader, which isn't what it wants. It needs this var, and you hit play, it will just do nothing. You won't get a warning, you won't get a crash, it just won't work properly. So debugging these can be very, very tricky. You just have to get everything perfect, and you have to use the best static analysis you got, because if you just launch and it doesn't work right, it won't tell you why. You just have to figure it out. It can be very difficult to code these shaders for that reason, and it's probably why it's such a generally high-paying job. I believe it's high-paying. And a quick Google search just reveals that yes, it is a high-paying job with an average of 133K per year. A lot of math involved, as you might have guessed or already know. There's just so much math involved in these shaders once you get deep into them and start doing special effects. All right, very good. Okay, so let's just make sure we have this correct. Put that in there, and I think that's going to do it for this tutorial. Thank you all so much for watching. I hope you've enjoyed this or learned something from it. Don't forget to hit all the buttons. Leaving a like really helps. Also subscribing if you want to see future content, future coding stuff, and other stuff I do. I've got a lot of variety. Weird way to word it, I know. I have a pretty large variety of stuff I'm planning on doing this year, aside from tutorials, like some documentaries and stuff. I'm trying to do 2 videos a week, and I'm sticking to it the best I can. Although I will admit it has been a bit of a challenge with all the stuff going on in the world. I've been a little distracted, but I'm going to keep trying to pump them out, and hope you guys are all doing well. I also do have a Patreon, and I want to make a special shout out to my patrons. You guys are really keeping me going a lot. Actually, I know that sounds cheesy, but it really does mean a lot, and I don't think I'd be doing 2 videos a week right now if it weren't for you guys. So if you want to help keep this going, feel free to sign up down there as well, and we'll be in touch. I'll be in touch. Appreciate you guys yet again. See you next time on Code Tech and Tutorials, where we will be talking about something, or OpenGL if you're just going to the next tutorial. All right, peace. Like I belong in Cyberpunk.